Hey, welcome back. In this video we are going to learn how to name carboxylic acids and nitriles. Let's start with the carboxylic acids first. We drop the E and we add the eoic acid to the alkane name, corresponding name. And the carboxylic acid is this group here. It contains a carbonyl group and an hydroxy attached directly to the carbonyl group. It has a lot of common names accepted by UPAC for carboxylic acids, such as acetic acid, the one found in vinegar. The UPAC name comes, for example, at this one, 1, 2, 3 carbons, propanoic acid. Okay, propane, the E here is dropped down. If you have the carboxylic group attached to a ring, the carbon at the carboxylic group is not numbered. The numbering started from here. So in this case, it's going to be 1-cyclohexene carboxylic acid. So it's not going to take this oic acid, but it's going to take carboxylic acid. Okay? Another common accepted name, benzoic acid, for example. We are going to see examples for this rule, to apply those rules. Nitriles. Nitriles, for example, acetonitrile, benzonitrile. As a common accepted name, the E is not dropping now because you do not have two volvae attached. So alkane name plus nitrile, propane nitrile. In case you have the nitrile group in a cycle, for example, in this case, the numbering starts from the carbon directly connected to the nitrile group, not to the carbon that forms the nitrile group. Okay, so in this case, 3-methylcyclopentane carbonitrile. Okay, carbonitrile. For the carboxylic acids, carboxylic acid. For the nitrile attached to a ring, carbonitrile. Okay, let's move to the examples. Give the names for the following structure. Let's start with the first one, that is a carboxylic acid. So numbering is going to start from this carbon. If it's a straight chain or a branched chain, you are going to count also the carbon at the carboxylic group. But if it is attached directly to a ring, you're not going to count that. So 3,4 dichloro butanoic acid. Right? For point B, here, what do you have? You start counting from here. 1, 2, 3. So is 3-methyl, 1-cyclohexene, carboxylic acid. Cyclohexene, we acknowledge here 1 for the position of the double bond, right? Let's move further. In this case, you have 1, 2, 3, and so on. So the position of the cyano here at this carbon is going to take the number 1, and after that, the number 2 is going to correspond to the position of the double bond. So the name is going to be 2-cyclopentene carbonitrile. Right? So 2-cyclopentene carbonitrile. Let's move further. What about in the case that you have a nitrile group and a carboxylic group? Nitrile, in this case, is going to be named as cyano, as a substituent. So at what position is this cyano? Ortho is this position, meta is this position. So it's going to be meta cyano benzoic acid. Right? Let's move further. What about in this case? In this case, I'm going to show above a table. This is the substituent that is called benzoyl, right? This kind of substituent is that when you remove the OH group to the carboxylic acids, it takes the oil, like propioyl, benzoyl. So it's going to be benzoyl in the meta position, meta, benzoyl, benzonitrile. Right? And the last one, point F, in this case, you have a triple bond, 1, 2, at the third position, 4, 5. So is as a long name is going to be 3-pentyne oic acid, right? 3-pentyne oic acid. What about this one? If you could name this one, leave that in the comments down below, and I will check if you name it right. Okay, for the table that I was talking, all those commonly accepted by UPAC names that you need to remember, if you give the UPAC name is fine, but some you're going to find, for example, acetic acid. Anyway, if you remove, for example, let's keep going to this benzoic because we named benzoyl. So if you remove the OH here, it's going to remain as a benzoyl substituent, okay? We saw some cases in the last video. Thank you so much for watching, and look forward to see all of you at the preparation and the reaction of carboxylic acids. Peace.